So what are we looking at here? Oh, this was not the file today. Okay. Ah, well, I guess we're not going to be able to open it up today. I haven't figured out how to get it out of Dropbox.
All right.
Was that your final test or something? I was able to kind of look at it horizontally on my phone.
That was just something. We can go over it whenever we can open it up.
Okay.
It was questions from a practice ACT test.
Oh, okay. Okay. I've got, okay, yeah. Are you taking the ACT this summer?
Yes, yes, sir. In
When are
July.
you going to take it? In July?
Yes, sir.
Well, we definitely should spend some time on that. I do a lot of ACT tutoring.
Great.
It's significantly less than calc. In other words, what it's basically going to be a review of is algebra and geometry.
That's what it seemed like on the practice tests.
Do you want to work on some practice ACT questions, or do you have a need to look specifically at that one?
Sure, we can work on some practice ones.
All right, let me find some ACT tests here.
Yes, sir.
I got tons. Always found the McGraw-Hill ones to be pretty good. Yeah, we'll start on test one. So I've got like 8 of them in here. Have you taken the ACT before?
Yes, sir. I took it once before in 7th grade.
Really? The full ACT
Yes, sir.
test?
Yes, sir. It was part of a Duke tip organization.
Oh.
Well, Duke University did something. If you scored high enough on the standardized tests in 7th grade, you got to take the ACT.
Cool. Hold on, I gotta look at this in a different way than I used to be able to look at it. Not sure what Windows has done with their software, but it's been affecting me for a while. I'm not sure where we should start. You want to just start at the beginning and see?
Sure.
In other words, I suspect you're going to handle all these easy problems pretty.
Yes, sir. Of
and
course.
They do go in order of difficulty.
Is that right?
Yes, definitely.
Okay.
Both the SAT and the ACT. Yeah, they start out easy, go to medium, go to hard. So the general strategy that you want to employ is there's like 60 questions. Do all of the ones you can do. First pass through. Second pass through, do all the ones you think you can do. And third pass through is going to be all the super hard ones. If you have time and get to those, fine, you can work on them. But at least you get the easy and the medium ones answered.
Yes, sir.
So, here, let me find something that we at least, how about number 2? I always kind of have a logic question on there.
Okay. Horse faster brown. Horse A is not brown. Horse B runs fast. Which of the following statements is true? Horse B is not brown. Oh. Okay. That's horse brown. It's brown. All horses run. All brown horses run fast. Horse A runs fast. Both. That's going to be G.
Okay. Yep. Hold on. No. It says horse A is not brown. Oh, I'm sorry. You said G. Okay. You got it. All right.
All right. So which one are we doing, 3 or 4?
3. Yeah, I'll try to put the problem we're doing at the top of the screen as we go through these.
So that's going to be 7.
Okay. 4. I won't say anything about easy ones if you get them. We'll just keep going until you have one you have problems with.
Yes, sir. So that's going to be 30.
Okay. Number 5. Do you have your calculator? Because they do allow you to use your calculator. All math.
Yes, sir. Let me get my calculator.
Okay.
Okay.
Having said that,
Yes, sir.
you don't need your calculator. And sometimes the calculator can lead you in the wrong direction. Frequently,
Yes,
we'll
sir.
put problems on there where the first thing people do is grab their calculator and all of a sudden they don't know how to answer it because that's not the way to do it. So be
Yes,
careful. Only use that calculator if you know it's speeding you up and you know precisely what is needed. All right, so number 5.
Okay.
Tell me how you're going to do number 5.
I'm going to multiply 6.6 times 0.8.
Good. That's it.
So that's C.
Okay. Number 6. Now they're going to start to get a little tougher.
Plus B. Okay. So it's going to be. So that's going to be K.
8 plus
K.
9. Hold on. What's the value of A? Oh, yeah, you got it. Sorry. I hadn't read the question properly. Which one can't be? So there's 4 right answers and 1 wrong one.
Yes, sir.
Okay, this principle for number 7 is they ask these kind of questions multiple times on this test where you have parallel lines and transversals. In other words, AC is parallel to DG, and
Yes,
both
sir.
of those slanted lines are transversals.
And because angle CBF is 40, and because those lines are parallel, BFE is going to be 40, which means that angle BFG is 140, and that is D. Is that right or is that wrong?
No, you're absolutely right. When you have the only real principle you need when dealing with parallel lines is there are 2 angles created, and only 2. And every other angle in the picture is equal to one of those 2 angles, and those 2 angles are supplementary.
Yes, sir.
So we can tell by looking at that picture that F has to be supplementary to 40 degrees.
Yes, sir.
All right. You're not going to have any problem with 8. Let me just keep going down. 9.
C.
There's absolute value markers around the 1 minus A.
Yes, sir.
So what's that? Oh, you said C. Yes. Okay, I didn't hear
Yes, sir.
Thought you were saying C. Number 10.
Okay. Oh, wait a minute. This one. Oh, so K is equal to A.
Yeah. And basically what you're doing here is solving two simultaneous equations using the substitution method.
That's right.
In other words, if those two C's are the same, and they are, then AB has to equal KB. And then A
Yes,
has to equal K. So, all right. Hold on, let me close this door.
yes.
Stay outside. All right, how about 11?
Thanks, 3 to the 13th. Okay, so that is A.
Okay. Another thing that you want to make sure you're good on is those exponents, the three rules of exponents.
Yes, sir.
12?
H. Oh, well, yes, H.
How did you do it? You did it algebraically?
Um,
Let me suggest back solving.
mentally, I set them equal to each other.
Let me suggest back solving. Because x is in the denominator, it makes it a little bit harder to think about. But let's talk about back solving anyway, because it's a super technique for answering problems that are hard. I don't know that this qualifies, but let's talk about it anyway. If you're going to back solve it, which one are you going to start with?
Back solving? What?
Back solving is where you test each of the answers and then pick the largest one that makes that inequality true.
So would you start with 28?
Absolutely. That's my point. And then you have the following two. Whoops. I don't know where I was at on the screen. I can't see. Then you have 2 over 28 is greater than or equal to 1 over 7. Is that true?
That is not true.
Okay. And so now you just work your way backwards. Is 2 over 15 greater than or equal to 1 over 7? That is not true. And then the last one you're going to try, 2 over 14, is that greater than or equal to 1 over 7? And the answer is yes.
That is true.
Now, in this particular problem, back solving wasn't so expeditious. It took 3 tries. But you get my point. There are going to be problems where back solving is going to save you a lot of time. I'm sure we'll come across some. Let's see. 13.
Okay. Oh, okay. So that's, hold on. Oh, D.
Which one?
D.
D, yeah.
As in.
Notice the trickery. Notice
give you.
the circumference has nothing to do with anything.
That's right.
And yet they put that in there. So beware that just because something's in there doesn't mean it's needed. Is all we're taking is 5/12 of 360 degrees.
Yes, sir. Okay.
Just tell me how you're going to do this. In other words, you don't need to actually do it. Tell me how you're going to do it.
Okay, so you're just going to add them together and divide by 5.
Yeah. Again, the 730 has nothing to do with anything.
That's right.
15.
Okay.
Yeah. Once where we find where we need to start, then on subsequent practice tests, we will just skip the easy ones and go straight to maybe the midpoint or something.
Yes, sir. Okay. H.
Okay. 17.
70% of x equals 90. 150. D.
Okay. Again, you could do this without setting up the algebraic equation. In other words, if I'm going to do this strictly by algebra, then I'm going to write this times x equals 90. Solving that, you get 0.9 divided by or rather 90 divided by 0.6 to get the answer. But you don't need to do it algebraically. You just need to start plugging, pick what looks like it could be in the ballpark and see if that's correct. So we'd even start there. Boom, you have your answer. 60% of 150 is 90.
Yes, sir.
And there is a beauty in this back solving technique that we haven't quite seen yet, but we will. And where you always want to start in a general back solving problem is with the second low or the second high. Not in the middle, not on A, not on E. That's with a general back solving problem. The one previous to this where they said, what's the highest value? Well, that's a different story. Then you always start with the highest value they have on there and work your way down. Or if they said, what's the lowest value? Then you'd start with A and work your way up.
Yes, sir.
All right. Number 18. Typical, very typical word problem. So how about trying to solve this by back solving?
Sir?
Try solving this by back solving. And work me through how you're going to do it by back solving.
So you would pick either G or J,
Okay.
and you would plug that in as the price of one drink to the first equation, and you would get the cost of
So let's pick
one
In
box.
other words, let's actually go through. Go ahead, you pick it.
All right, G.
Okay. So if G is correct, then the price of popcorn is what? Price of popcorn would have to equal $3.25.
So popcorn.
Is my math right? 325 plus 185 is 510.
Yes, that's correct.
Okay. So now let's see if that makes the second sentence proper. You have 2 popcorns, that would be $6.50, plus 1 drink, which is $1.85, and you get $8.35. Bingo, we got lucky. I'm almost sorry we did, because let's do it the other way. Yeah, now I got to figure out this eraser system. Maybe I can erase everything. Did I have that? No. Oh, gosh. I want to show you the other way because this demonstrates the beauty of the thing. So here, let me try to write. Let's pick J to start with. Okay?
Yes, sir.
So the price of a drink equals $2.55. Oh my goodness. What did I get myself into here? That would make the price of popcorn. What's 510 minus 255? 255.
Yes.
Now, when we go to test that in the second equation, we get 2 of those, which is 510 plus 255.
Yes, sir.
Well, that does not equal 835, and it does equal a number that is less than 835. And what that basically tells you, oh, this was a horrible one for me to pick, is that you have to go to a lower number. Let's wait until we get to another one. This one is just tricky enough that it's not readily immediately knowable, at least not to my brain, that when you get a number less than 835, that you need a price on the drink to go down. Usually back solving problems, once you test either the second lowest or the second highest, you know exactly which way you have to go, and that tells you the answer.
Yes, sir.
As to what to test next. It doesn't tell you the answer, but it tells you what to test next. Now, if it tells you that you have to go higher, then you're done. In other words, let's say you did a back solving using G and it was not correct, but it told you you needed a lower price. Well, then immediately you would choose F and you would go on.
Yes.
So back solving is beautiful in the sense that you only have to do at most 2 of the numbers, work them through the equation. You never have to do more than that. Just a second, let me fix this. You see that at the top?
Yes, sir.
Okay.
So, oh boy.
They make this a little tricky. It's not quite what you think it is when you're first doing it. So give me the total cost of the bill when he gets to the cash register.
Without the, oh wait, no, hold on. I know what I did.
What are you going to do? You're going to multiply 1.07, correct? Times something?
Yes, sir.
Times 2 times 899.
Okay. Oh boy.
In other words, you use the same technique you did when we were looking at discounts. You didn't multiply by 20% and subtract. You multiplied the thing by 80. Well, when you're talking about tax, you do exactly the same concept. You don't multiply by 0.07 and then add it. You just multiply the cost by 1.07 directly.
Okay, so do you want the cost or the answer?
Cost.
Okay, so $19.24.
Okay. Now, if you were too quick to go on this thing, you might think 76 cents has to be the answer, and that's one of their answer choices. But that's not. If you read the question, you have $21 bills, 19 of which will take care of the 19. How much will you need in coins if you want to have exact change ready?
24 cents.
Yeah. All right. $20.
Okay. Oh, okay. That's G.
Okay. You took the cube root of the first one first as your first step?
Yes, sir. It took me a minute to remember what it was, but yes, the cube root.
21.
Okay.
Tell me how to do, what's the best way to do 21?
Would you just convert them all to decimals, or would you do it
Absolutely.
something like that?
Absolutely.
All right.
In fact, they're not even close, so you don't really even need the calculator here. In other words, I'm doing all this in my head, and I didn't even need the decimal at all. I just needed the whole number.
All right. So it is B.
Okay. Number 22.
Okay.
And tell me how you're going to do it.
So, would you set that up algebraically, or would you back solve it?
I would back solve it. This is a perfect one because it's fairly hard to set it up algebraically, even thinking about it. Turns out that it's not that hard, but just the fact that it's not doesn't come to your mind immediately, and yet back solving it's going to work beautifully. Where are we going to start?
All right, let's do H.
No, don't start in the middle. Start with the second lowest or the second highest.
All right, so let's do G.
Okay, since we have a choice and they're equally as good, Let's choose the number that's going to present the easiest math for our first calculation.
All right, so J.
Perfect. So we're going to assume J, which would say that 9 plus 3 over 13 plus 3, is that equal to 3/4?
Okay. That is.
It is. And I don't believe that's accidental. I think that they're trying to reward students who know how to back solve and who know where to begin. And they make that the answer. If that was not equal to 3/4, then if you know which direction you need to, let's say you know you need a bigger number, well then you know the answer is K. If you need a smaller number, then I suppose I would do that one next, even though the math is much more complicated on those.
Yes, sir.
You subtract 1 1/4 from the numerator and 1 1/4 from the denominator. There's a lot of arithmetic that needs to be done to reduce that and see whether it's 3/4 or not.
Yes,
although the calculator could assist you in that problem. I don't know. But I don't believe it's accidental that J was the correct answer.
Yes, sir.
23?
B.
Okay. So you know, you don't always have to start there and subtract that one. And then put it over starting there and subtracting that one. If that's the way you did it, you got this, right?
Yes, sir.
Is that the way you did it? You can go the other way, as long as you go the other way on both of them. And
that's right.
This one, it's a little bit easier to go the other way because the numerator becomes 4 minus a minus 7, and the denominator is all positive numbers. And positive numbers are always easier to work with. And that immediately gives you 11/3. So just remember, you can go either way, you just can't mix it up. You can't go one way with the numerator and a different way with the denominator.
Yes, sir.
All right. 24. Now we're starting to get into some more difficult questions. And they do love prime number questions.
Okay. Greatest prime factor. Okay. How would you solve this one?
Prime factor? You know how to find the greatest prime factor of 38?
Could you refresh me on that?
Start with
Is there
38
enough?
and you split it in 2 if you can.
Okay.
And I can't split it anymore. Those are the only 2 factors of 38. So which one's the greatest prime?
19.
Okay, so P equals 19. Now let's do 100.
Okay.
What's the first step?
Split it in 2. Split that in 2.
The 50.
That's right. Would we split that by 5?
Yeah. What's the greatest prime factor of 100?
5.
Okay.
Okay.
5 plus 19
So
is 24.
H, 24.
Here, I want to, 25 is a pretty cool problem. Let me get it without all the writing on it. Sorry, I got to remember I'm using a slightly different technique than I normally do here. I'm using the drawing capability of Paint.
Huh.
Which actually works better as long as I can remember to keep my scribbling next to the problem and not take up the whole page. My other technique doesn't matter if I take up the whole page because I got to erase and start from scratch.
Yes, sir. All right.
So number 25. Tell me how you're doing that, how you're trying to do it.
Okay, so, okay. I just found the square root of 289, and that is 17. And so t plus v is equal to 17. And if t times v is equal to 30, that's 15 times 2. So t is equal to 15, and v is equal to 2. So that means 229, that is E.
Okay. I'll give you a slightly different way to do it. Let's go ahead and expand this.
Okay.
What's it expand?
So that's going to be t squared plus 2tv plus v squared.
Now, we know what they're telling us is that right there, right? And that's all equal to 289.
Yes,
So let's
sir.
go ahead and substitute TV equals 30. So now we get t squared plus 2 times 30 plus v equals 289. Now subtract 60 from both sides and you solve for t squared plus v squared without actually solving for t or v. You don't need to solve for t or v, you just need to solve for t squared plus v squared. But the way they want you to do this problem is this way right here.
Okay.
Now, it did occur to me as I was thinking about this that back solving actually kind of works. I didn't think it did, but back solving only works if you know how to expand that. You have to know that that expands to t squared plus 2tv plus v squared. That's really the essence of this problem.
Yes, sir.
Even though there's other ways to solve it, it's still what they're looking at, the way they're wanting you to solve it. In other words,
yes, sir.
The quickest way.
Okay.
Another question about rules of exponents.
All right.
So what are you going to do as a first step?
So you're going to multiply 3a plus 5 times 4.
Which is?
So that's going to be 12a plus 20 is equal to 44.
All right.
So it means that 12a is equal to 24 and a is equal to 2.
Oh. Okay. Questions always bother me a little bit because I don't actually think they have log questions on the test. And if they do, they're the most basic of all.
Yes, sir.
You know the answer to this?
That is B.
Okay. So you're good with logs?
Yes, sir.
Okay, cool. 28.
J.
Okay. You see the shortcut? The shortcut being is that the only one you have to solve for is the x coordinate.
That's right.
Immediately find that it's 10, and then if you glance at the answers, you're done. In other words,
Yes, sir.
any effort you spend finding the y coordinate is wasted.
Yes, sir.
Okay. Doesn't save much, maybe 10 seconds of work, but all those 10 seconds is add up.
Yes, sir.
29. It's always one or two questions on conics. Actually, they're never on all of the conics. They're either on circles or ellipses. We'll review ellipses as soon as we do this problem here.
That's root 14, right? D?
Yep. Okay. So the circles are pretty easy. That's supposed to be r squared, okay? In other words, that's the general formula. X minus h quantity squared plus y minus k quantity squared is equal to r squared, and h and k are the center of the circle. So where's the center of the circle?
So the center of the circle is going to be 4, 1. 4, 1. Is that right?
Okay.
Okay.
Yes, it is. Now, as long as we're looking at this, let's talk about ellipses.
Yes, sir.
General equation of an ellipse is, do you remember it?
The equation of an ellipse, that is, it's, okay, x minus h squared, and is that over a?
Yes, over a squared. They're both top and bottom are both squared. And the rest of it?
Bottom is a squared. And that is y minus k squared over b, y minus k quantity squared over b squared.
What's the rest of it?
Is equal to, that is,
it's 1. Let me tell you how a way to remember.
That's right, 1.
If this ellipse was a circle, then a and b would be the same thing. And if we multiplied both sides by it, we would have r squared on the other side.
Yes, sir.
Okay? So that's one way to think about it, and remember that it has to be a 1 over there. But both ellipses and hyperbolas are equal to 1.
Yes, sir.
Circles are the only ones that are equal to r squared. And parabolas, they don't tend to test on parabolas. I've never seen a parabola question on one of these exams. They have questions on quadratics and maybe a graph of a parabola, but not parabolas as conic sections. In other words, they don't ask you about the directrix or the focus point of a parabola.
Okay.
And in general, they don't really ask you about any of those with circles and ellipses either. They just want you to know those general formulas, because they'll give you an ellipse, a specific, and they'll say, what's the center of this ellipse. So as long as you know the general formula, you can always do the rest of it. Obviously, in this ellipse, that is B.
Yes, sir.
That is A. And they're always different, because otherwise it would be a circle. And ellipses do have a lot of very interesting properties, but none of which they're going to ask you about on the exam.
Yes, sir.
All right. Always 4 trick questions, precisely. And they're always relatively easy trick questions. You don't need to remember your hard trig, you just need to remember your basic trig.
Yes, sir. Right motion cosine of A. 12 over 13, H.
Good. So you recognize that that was a 5, 12, 13 right triangle.
Yes, sir.
Which was the first step, and then just knowing SOHCAHTOA is the second step. And boy,
Yes,
they get a little bit more difficult than that, but not a lot. If you know SOHCAHTOA, you're going to get 2 of the problems right.
All right.
So 33.
Okay, so let's just put in that in slope-intercept form. Okay.
Okay, so what is that?
That is 2 over 7.
Well, okay, let's see. I have to do it because I haven't done it. I go ahead and split those up right there because they're wanting the y-intercept. All right.
Yes.
$34.
Okay. So F.
Okay.
Is that right?
Yep. Yeah, the key here is that's a solid, that's not the same line as the axis. The axis is a skinny line, that's a thick line. So wherever that line is the solution.
Yes, sir.
In other words, you can't say that it's both greater than -4 going all the way out that way and that it's less than -6 going all the way that way. It's only the solid line we're asking about.
Yes, sir.
It's a pretty cool one. Hold on, let me shrink this just a tad so we can get...
What is the question asking? Okay, what is the perimeter?
Yeah, hold on, let's see if I can... There, that should be... There, what in the world? Okay, they're asking for the perimeter of this. You know what? We don't need multiple choice.
Is this...
The multiple choice isn't going to help on this. You're going to have to figure out how to do the geometry. In other words, we can't back solve it. We can't take one of those answers and put it in and work backwards. Tell me what you're thinking along the lines of one really good thing to do with the geometry questions like this is add lines if you need to.
Add lines.
Add lines.
Okay.
Where am I going to add a line?
Between the 2 points on the bottom.
Yes. In other words, I could add the line straight across the point at the top, that vertex, but I don't know that distance. So that's not going to help a whole lot. But if I add this line down here, now let's figure out some stuff. What's that length?
That is 6. Oh, okay. And it's a 60, 60, 60 triangle.
Yep, so that's an equilateral triangle, which means all 3 sides are 6.
That's right.
And now we know the perimeter. What's the perimeter?
Which means that it is 30. B.
Uh-huh. Yeah, in other words, you don't have to use any more. You got all 6 sides, or all 5 sides of that. It is 6 sides. measured, so you just add them up. Okay, 36.
Must be the real values of x and y. Okay, so that means H. Is that right? H?
Well, I'm thinking about it. It's been a long time since I've done this one. I'm trying to remember what the answer is. Think about it for a second. If they're both positive, that does not produce any problems.
Is that right?
Yeah, I'm trying to think if they're both negative. And here's where I'm having difficulty. I think I've always had difficulty. That is supposed to be that. Notice if x and y are both negative, the negatives cancel out and you end up taking the square root of a positive number, which is fine. But over here, it gives you problems. Because if one of them is negative, you can't take the square root of a negative number.
Yes, sir.
And it seems to me that we're looking at that here. What we're looking at is the square root of 3 times the square root of x cubed, all divided by the square root of 2y. All of that is equal to 4. Now notice that when I've rewritten it, y can't be negative.
Yes, sir.
X could be, but y wouldn't be. Couldn't be. Well, let's see if we can go through each of these answers and figure out if we can eliminate all but H.
Okay.
See if we can make a little bit of progress. X and Y must both be negative. Well, clearly that is not the case.
Okay.
They can both be positive. If I solve that, what do I get if I solve that? I get 3x cubed over 2y equals 16. And certainly, they don't have to be both negative.
Yes, sir.
Now, this is the real true question, is do they both have to be positive?
Yes, sir.
It's really going to come down to G or H, depending on whether or not one looks at it like this. J, clearly not, because if one is positive and one is negative, the result is a negative, I believe. Yeah, if x is positive and y is negative, then for sure you're taking the square root of a negative number. And if x is positive, or if x is negative and y is positive, you're taking the square root of a negative number. So definitely not J. No, they cannot have the same, they can't have any old value because you cannot take the square root of a negative number. And I can certainly figure out values for those two things that would make it a negative. So So it really comes down to G or H, and I'm not sure I have an answer for you. As to which is mathematically correct. If you try to solve it like we did up here, then it does look like they can both be positive or they can both be negative. So I'm inclined to think H is the correct answer. And this part over here bothers me a little bit, the same way that this one does. In other words, in that very first one where I said the root of x over y, we're certainly taught that that's equal to the root x over the root y, in which case they can't both be negative. But perhaps because the negatives cancel out before you do anything, you can do it. I honestly don't know. As I said, this particular problem has always given me a little bit of difficulties. I think I have answers. I can certainly look the answer that yeah, well, let's do it. We only have a minute or two. 36. So we think it's either, you think it's H. I kind of do too, but it's either H or G. So let's have a look at number 36. This might be enough to see it. I forgot to open it with paint. Yeah, I can see it. It is H. Okay. Which is what you had originally said. All right.
Yes, sir.
So you good to go for today?
I think so.
Okay. I will make a note as to which question we got through, number 36. So that next time we can start at 37. And if you want to do that, I'll let you totally direct. If you want to do more of this or 100% of this until you take the test and put the calculus off until after this, that's fine with me. Or whatever. If you want to do half and half, that's fine with me. I'll let you make that decision. It's a pretty important decision what you get on that test if you're trying to get into college somewhere. So I'd be inclined to recommend we work on the ACT. I definitely think I can help a little bit.
I think I'd like to do that.
Okay. So we'll plan on doing that. Next Tuesday. My son's coming to visit for a week, and I'm kind of trying to cancel everything out. I don't have to cancel it. It's online. He can... I was thinking if it would bother you if we didn't do one next week, and maybe if you want to catch up, we could do two after that, the next week. What do you think?
That might sound good.
Does that work?
Yes, sir.
We'll reschedule next Tuesdays for the following Thursday. Does that work for you?
What time on Thursday?
Well, we could do the standard time if you want, or we could move it. I got quite a bit of flexibility. I can move it later. I can't move it much earlier.
I guess I wouldn't be able to do it any other time.
Okay, so what does that mean? I'm not quite sure what that means. I mean, you don't want to do it on Tuesday and Thursday?
I can't do it on Thursday.
All right. Well, I tell you what. Let's just go ahead and plan on doing it next Tuesday then. I don't want you to miss a session, especially if you got a test, the ACT test coming up. And it'll be fine. We'll do our regular hour session on Tuesday.
Yes, sir.
Sound good?
Sounds good.
All right. Have a good one. Talk to you next week.
You too.
Bye-bye.
Bye.